1 for section 9.1. We want to determine the null and alternative hypotheses and the setup type for each of these three scenarios. So this first one, the Medco Pharmaceutical Company developed a new antibiotic for children. 2% of children taking competing antibiotics experience headaches as a side effect. A researcher for the FDA wishes to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. Since we are talking about a percentage here, the parameter that we're going to be using is going to be a parameter P for the population proportion. So we need to map out our null and our alternative hypotheses. So both of these have that parameter in it. Those are fine. We were told right here, and let me highlight this, that 2% of the children experience, when taking those competing antibiotics, they experience headaches as a side effect. So because of that, that's going to be a null hypothesis. Okay, we were already told before doing any type of experiment that the percentage of children taking competing antibiotics experience a headache as a side effect 2% of the time. So because of that, our null hypothesis is where that percentage is equal to 2%. And as the last sentence here says, the researcher from the FDA wishes to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. Okay? We want to determine if this percentage now is greater than. If it's greater than 2%, once this one's actually right. Whether or not it's greater than that 2% value. So greater than 2%. Okay, so this is using one of those one-tailed hypothesis tests, since we want to know about it being greater than 2%. The second one has the Blue Book price of a used 3-year-old Chevy Corvette ZRI is $86,012. Grant wonders if the mean price of a used 3-year-old Chevy Corvette ZRI in the Miami metropolitan area is different from $86,012. So the parameter that this one uses, if I could actually write correctly, that would be helpful. The parameter is going to be the mean, and the null and alternative hypotheses both have that mean. We were told here that according to the Blue Book price, it is $86,012. So the mean is equal to $86,012. While the alternative, we want to know if it's different. Now, we're not told if it's greater than, less than, just that's different. That means the alternative then is not equal to $86,012, which means we have that two-tailed hypothesis test here. This one is one-tailed, and this one's two-tailed. And then this bottom one, the standard deviation of the contents in a 64-ounce of bottle of detergent in an old filling machine is 0.23 ounces. The manufacturer wants to know if the new firm machine has less variability. This one deals with the standard deviation, as specified in the beginning part of this question. So standard deviation. And then mapping out these hypotheses. We want for this so we have our null hypothesis and our alternative. Okay, and for the null hypothesis, we are told in the question that the standard deviation is 0.23 of an ounce. So the standard deviation equals 0.23. The alternative is when that standard deviation has less variability. So it's less than 0.23 of an ounce. Again, this is one of those one-tailed tests. This one was a two-tailed test. And this is a one-tailed test as well. One-tailed. Okay? So those are the three types and three basic setups then of a hypothesis test. All of these alternative, all the null hypotheses, all of the null hypotheses are always an equal relationship. Always, always, always. The one that changes is always the alternative. Whatever number you gave inside of the null hypothesis is always the number inside of the alternative one. The only thing that's going to change in the alternative hypothesis is the symbol that's used if it's greater than, less than, or not equal to.